In this particular lecture, let us try to understand what is knapsack problem and how to approach this problem using dynamic programming. So in this dynamic program, we are going to use a table that will help us to solve this problem. And there's another method to solve this knapsack problem, that is with the recursion. And one thing that I have to mention about recursion is it will take stack and a lot of time in the recursion, because the function has to call itself until the problem gets solved. So in spite of this, we used another a best approach, that is dynamic programming. And let us see how the problem can be solved using DP. So for that, let us make a DP table and let us understand knapsack first. So it is either that you can place an element or not. So you have only two options. You can either have it or don't, or not. It's not like you can cut it into two pieces and have it. So if given, you need to either choose it or exclude it. So here in the data, we have the total capacity as 10, whereas the weights are given as 1 2 1 3 4 6, and the associated values are 20 30 10 50. The approach is going to be very simple, and let us start it. So first of all we have to do is just write down the numbers from 0 until 10, because the capacity is 10. So 0 1 2 3 4 5 6 7 8 9 and 10. Then the values, they are 1 3 4 and 6, and the weights, these are the weights and the values associated to the weights: 20 30 10 50. Okay, these are the values and these are the weights. So just think of 0 as empty and 1 as just think of a drum or a bowl that has only units, one space, and 2 as a stack that's having two spaces, and 3 has the stack that's having 3 spaces, and 4. So like this, just think of 10 as a stack having 10 spaces. Okay, just imagine that they have 10 spaces in that particular stack. And see, the first step is very simple. If you are given 0 weights, if you have nothing to put, then just copy zeros. And the same here. Okay, now if you were given, note the point, if you were given this is 1 block, this is 3 blocks, this is 4 blocks, and this is 6 blocks. Okay, because I've mentioned this to be a stack, the stack can have blocks in them. So if you were given only 1 block and you were given only a stack with 1 space, so all that can the stack contain is only 1 block. So just simply put this block into this stack. So how many can you fit into it? Only 1, right? So write its associated value 20. And if you're given 1 block and you have 2 spaces, how many can you fit? If you were given 1, you will be able to fit only 1 block into 2 stacks. Despite of any number of blocks, spaces you have in the stack, if you were given only 1 block, you can only put 1 block into it, irrespective of the size of the stack. So just copy 20 20 20, 20, 20. See, remember that we are handling knapsack 0 or 1. We can either have it or not. So if you were given only one block, and irrespective of the stack size, you will be able to put only one in each, because you were given only one. So note this point. This is the reason I am repeating this. And if you were given three blocks, if you were given three blocks, and if you have only one space in the stack, so you have two options now. You can either choose the maximum from the previous cell, that is this thing, or you can include the elements. See, because we have only one space, and if we were given three blocks, will we be able to accommodate these three blocks into this one stack space? No, because that will overflow. And what do I mean by overflow? See, you have only one space, and I'm telling you to accommodate three blocks. How can you accommodate these three blocks into one space? If the stack has only one empty space, you were given three blocks, how can you accommodate it? It is not possible. So when it's not possible, you need to copy the value from the previous cell. And what's the previous cell? It's 20. And for 3 you will be doing that for every number until you reach 3, because when you are given 3 stack spaces, and if you have 3 blocks to accommodate, you can do it. But the thing that you have to concentrate at this point is it even necessary? Does it even make sense? If you were given 3 stack spaces and 3 blocks, and by accommodating these 3 blocks into these 3 stack spaces, are you making any profit? So you need to concentrate on the profit now. So because I've given you 3 stack spaces and 3 blocks, if I accommodate all these blocks into the stack, am I making a lot of difference? See, on including them, I would get 30. If I include, I would make 30. If not, I will be making 20. So if not, so if I skip, then copy previous, and from this copy I'll be receiving 10. So we need to compute the maximum of include and skip, which means the copy of the previous cell. And what is the maximum? 30 is the maximum. Because 30 is the maximum, we are going to accommodate these new 3 blocks into these 3 block spaces. And now for the fourth stack. Now see, no, 1 second, I'll erase this. At this point, we have 4 blocks in the stack, 4 stack spaces, and we were given only 3 blocks. So you can accommodate the first block here, second block here, third block here, and this is an empty space. This is a problem of underfitting. So when you have empty space, which means you can include the other blocks as well. Until this point you have included all the 3 weights, but there's another block which can also be accommodated. So how will we get that? For this, the formula is current capacity. So current capacity I minus current weight I, which is nothing but 4 minus 3. 1. So this is the one empty space. And how to fill this one? Just go to the previous row and get the first column's value. For this particular row, this is the previous row, and what I'm saying is get the first cell value, because this is returning 1. The first cell value is 20. Now if you include these three, which is 30 plus the one block will be 20, we are making the profit of 50 on inclusion. If we skip, we would make 20. Now you tell me, is 50 maximum or 20? Because 50 is maximum, we will write 50 here and then continue the program. So on 5, let me repeat the same thing. It is between 20. I'll write the formula here. So it is simply 20 from the previous cell, and 5 minus 3, that's 2, and that will be 20 for all the cases. So which will be 5 minus 2, 5 is 30, 50 and 20. Because 50 is the maximum value, we will copy the value 50, and I'm simply copying 50 because I know that I'll be getting 20 from the previous row and nothing else if I include. So I've just copied 50. And for the next, I'm erasing this part. Now I have how many spaces? I have unit space, but I want to accommodate 4 blocks into it, and this is not possible until the capacity gets to 4. So what we'll do is, if the condition is not matching, we will simply copy the previous cell values. 20, 20 from here, 30, and now at this point the current capacity is 4, and the number of blocks are 4. So we can accommodate all these blocks into what? This stack. But we need to make sure that the profit that we earn is maximized. If we include all these blocks into this stack, we will be getting 10 as the profit. So if we include is 10. If we skip from the top, it is 50. What's the maximum thing that we can get? What's the maximum profit that we can get? By inclusion, it is not going to help us anyway. So we will just skip this and choose the maximum value. And I'm going to do the same for the next thing. Now for this, what I'll do is current weight. I'll write the formula here. Current capacity minus current weight, which is nothing but 5 minus 4. 5 minus 4 is 1. And if I include from 1, I'll get 20. 20 plus 10. 20 plus 10 is 30, which is inclusion. 30, 30, 50. 50 is maximum. So I'll just copy by skipping. And because everything, okay, one second. And for this 6, we have 2. From 2, I'll be getting 20. 20 plus 10, so I'll be just simply copying this. And from 7 minus 4, which is 3. So I'll go to the third cell, third column, and I'll add 10 plus 30, which is 40. So 40 is less than 50, so I'll just simply copy it, and then I will check for the capacity 8. Now the capacity of the bag is 8, and The leftover spaces, the underflow, the leftover spaces are 4. So I'll go to the fourth column, which is 50, and by inclusion 10 plus 50, because 10 plus 50 is 60, that is greater than 50. I will not skip now, I will include 60, and because all the previous values are 60, so 50, so I'm just simply copying that. Now coming to the 6 blocks. So until 6 we can just copy the previous values. And on reaching 6, just look, okay, see, even if we include or get the maximum from the previous cell, they are both the same, so we can just simply write 50. And now if we look at this part, the current weight now is 7, and the weights are 6, which is 1. And on inclusion we will get 50 plus 1 space that we'll get from this point, that is 20, which is 70, and 70 and 50 skip we will be getting from the previous cell. So because 70 is greater, we'll just copy 70. And next, the capacity is 8. 8 minus 6 is 2, and from 2 we'll be getting 70 as well. And now the capacity is 9. 9 minus 6 is 3, and from 3 we'll be getting 50 plus 30, which is nothing but 80. So on comparing 60 and 80, 80 is maximum, and if the capacity is 10 and this is 6, we'll be getting 4, and from 4 what we'll be getting is 50 from the previous row's fourth column, fourth cell. We'll be getting 50, and if we include 50 plus the previous cell values 50, that's 100, and 100 is maximum than 60, so we are simply including it. So now the maximum profit that I can get is 100. So this is done by 50 and 50, 50 from the previous weight and the 50 from the inclusion. So the equations that we are going to that I've used in to solve this problem is I've computed the for every index I've computed them. Yeah. So at specific index, what I'm looking for is the current capacity of I minus current value of I. If the current capacity is less, if the current capacity of I is less than current weight of at I, then we will copy the cells from the previous row. Then copy the value of current cell I minus 1, and if it is greater or equal to, if current it is greater or equal to current weight, then what we are doing at this point is let's think of the example 4. Now what we are doing is we are trying to maximum, we're computing maximum from inclusion and skip. The inclusion is given by, how is the inclusion given? The inclusion is given by current value at I, current value at I plus current value at I plus the rest of the spaces which is underflown. And how will we get that? Current, yeah, we'll get that from current cell minus current weight of, and we want the previous value. So from the table, okay, so go to the table I minus 1, and what do I mean by I minus 1 is the previous row. So the previous row, from the previous row we need to get the cell based on this equation, and we need this for inclusion, and for skipping we just need minus 1 of minus CWI. So that's it. We need these two equations, equation 1 and this is equation 2, and that's it. We have solved the problem. Now I'm going to discuss about the code that I've used to solve this problem. See, this is the code, and we have used the bottom-up approach here, which is DP, using the dynamic programming table. And okay, see, if you observe, here are the mathematical equations. See, if the capacity is less, then based on the discussed equations, I have coded them as these in Java, using Java programming language. And okay, at last, these are basically the mathematical equations that I've previously discussed. Equations based on this condition. And at last, what I'm doing is I'm just printing out what are the values that what are the weights that I've added into the stack to maximize my profit. And this is the weights that I would get, using which I have maximized the profit.